Hello. In this video, I will do examples of compound interest. We're going to bring back the compound interest formula. So remember that an account with principal P if an account with principal P is paying an annual interest rate R, and compounding is being done m times per year. For example, if compounding is being done once a year, m is equal to 1. If it's quarterly, m is 4. If it's monthly, m is 12, and so forth. And if the money remains in the account for n times period, then the future value A of the account is given by this formula. The amount is the principal times 1 plus the interest rate over the number of compounding periods raised to the total number of compounding periods. So n, it's the same as m times t, where t is the years after, is the number of years. Okay, so I'm going to start with example 5. I'm copying this example right now. And we are going to find the principal. So upon the birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's college education. Assume that the account has an annual interest rate of 4.8% and that the compounding is done quarterly. How much must the parent deposit now so that the child will have $60,000 at age 18? So we know the interest rate. We also know that compounding is done quarterly. And we know how much the parents want to have after 18 years. So the amount after 18 years is going to be 60,000, and the number of years is 18. So we need to find P. Find the principal, that is how much should the parents deposit right now. So remember the compound interest formula. I'm going to write this one more time. And we're going to plug in all these numbers. So we want to find the principal, so we want to find P. We want to find the principal. So the principal times 1 plus 4.8% divided by 4 to the power of 4 times 18. That must equal 60,000. But 0.048 over 4 is 0.012. Then 4 times 18 is 72. And then 1 plus 0.012 is 1.012. So the principal is going to be 60,000 divided by 1.012 to the power of 72. So I'm going to show you on your calculator how you can plug this in. It's important to use grouping symbols. So this is 60,000 divided by 1.012 to the power of 72. So that's going to be approximately $25,418.76. So that's the amount that these parents should deposit right now in order to have 60,000. So that's $25,418 with 76 cents. So that's one application. The next application is to nominal yield. That's number 18. Let me copy the problem. Okay, so I will copy the instructions. And we're doing number 19. Savings institution often state a nominal rate, which you can think of as a simple annual interest rate and the effective interest rate, which is the actual interest rate earned due to compounding. Given the nominal rate, it is easy to calculate the effective interest rate as follows. Suppose that you invest $1 in an account paying an interest rate of 6% compounded monthly. Using the compound interest formula with $1 and 6%, we have that the amount after 1 year would be this year, 1.0617. So subtract 1 from that and convert it to a percent, and that's going to be the effective interest rate. So use this method to find the effective interest rate for the investment in the following exercise. So the nominal yield is 7.5% compounded monthly, and the effective interest rate is going to be all the interest earned during that year. That is after, in this particular case, after 12 compounding periods. So the principal is $1. The interest rate is 7.5. As a decimal is 0.075. And interest is compounded monthly. NT is 1. So the amount is going to be the principal times 1 plus the interest rate divided by 12 to the power of 12 times 1. So 0.075 over 12 is 0.00625 to the power of 12. And we are going to find the actual, well, the interest rate earned during that year. So this is 1.00625 to the power of 12. So to 4 decimals, that's approximately 1.0776. So the effective interest rate is going to be that amount minus 1. The effective interest rate is 1.0776 minus 1, or 7.76%. Okay, and the last example, we are going to find the interest rate. So we're doing number 33, in which we're finding the interest rate. Well, actually, I'm going to do, let's see. Actually, I'm doing number 43. So I'm copying the problem right now. So we're finding the interest rate. Sanjay has borrowed $400 on his father's watch from the Main Street pawn shop. He has agreed to pay off the loan with $425 1 month later. What is the annual interest rate that he's being charged? Okay, so if he's borrowing 400, that's the principal. And if he's paying 425, that's the amount after interest. So $25 are interest. So we need to find R. And then we know something else. We know that this is 1 month later. So M is 12. So T would be 112. That means N is 1. Is 12 times 112 or 1? So let's put this together. This is 400 times 1 plus R over 12 to the power of, or to the first power. That is equal to 425. So we need to find R. We are going to find the interest rate. And of course, we need to find the interest rate as a decimal. So that's what? That's 1 plus R over 12. That is equal to 425 over 400. And 425 over 100 over 400 is 1.0625. Subtract 1 from both sides, and R over 12, it's 0.0625. So the interest rate is going to be 12 times 0.0625. So when you multiply that, you'll find that this is 0.75. So the interest rate is going to be quite high. It's going to be 75%. So back to the question. So the annual interest rate is 75%, which is a lot. I'm just going to type it. Yeah, this came from this decimal because it was 75%. Okay, thank you for listening.